Well, hello guys. Here we go again. My name is Rafaela, and in this presentation, we're going to talk about my work with Professor Sandro in the astrophysics group with title Environmental Mapping of Post-Starburst Galaxies. So, post-Starburst galaxies, as I said in the last presentation, are a rare class of galaxies that have truncated starburst suddenly. So, we have a galaxy who formed a lot of stars. It's a burst. Starburst, burst is an explosion, so it refers to the intense star formation. And suddenly it stopped to form stars. And here we have desligado. Só para ver um pouquinho melhor. Só um pouquinho melhor. For instance, this galaxy, and here we have the spectrum of this galaxy. And as I tried to show you in the last presentation how to read this spectrum. So now you can see these absorption lines, and if you remember, this means that we have this galaxy pass through an intense star formation, because I can see this strong absorption lines here of the absorption lines. And by the other hand, we have here a small emission, or we haven't emission. And this means that this galaxy stopped to form stars. What is the life of a galaxy? It's form stars and not form stars anymore. So we have here a galaxy in the midst of the transformation. So it is very cool because it helps us to study the galaxy evolution through this object. Okay, the methodology of my work is we measure the equivalent width that we call EW of the H delta. This is the H delta line and the H alpha line. And we make this through this Gaussian fitting. So we make this Gaussian fitting for about 30,000 galaxies. So we use their optical spectrum. So optical, here is the blue color, and here is the red color, the rainbow. Okay, this is the optical spectrum from the Sloan Digital Sky Survey. That's the survey that we use in our work. So we define the post-starburst galaxies as those with H delta EW greater than 5 angstroms. 5 angstroms is about the flux I have here. This is 6. 8 EW. But what is EW? I don't know. And we are going to talk about here. What? Equivalent width is how evident is this line? How evident is this line when compared to the new level of the continuum? This is the continuum. Okay, the line of one galaxy. So we divide the flux absorbed here. So the area here, we divide this area by this new level, about 70. And so we have this EW for about 5. This is an example in which EW is for about 6. So huge absorption. And also, we don't want EW greater than -3. And not absorption lines to us is positive when, by the other hand, emission lines we have in this negative sign. But the line we are interested here is this line, not here, not this one. And this is for H delta, J, B, and this one is for the H alpha. I feel I increase the figure. In here we have lots of Gaussian fittings. It's just for you to see more details. And here we have the preliminary results summarized. So, after our work, we found 21 objects for 30,000. So, it's a rare class of galaxies confirmed as post-Starburst galaxies. And summarized here, we have examples of images of these galaxies. And here I have other results. The transitional nature of some of these objects was confirmed in this diagram. This diagram we have the star formation rate by giga-year, okay? And here we have the stellar mass of these galaxies. So it's very interesting, this diagram, because here we have each point here is a galaxy. And here we have about
2 minutes.
We have about 500,000 galaxies here. And we separate these galaxies in groups. Here we have galaxies, it's a symbol. High star formation rate, low star formation rate. And our post-Starburst galaxies is this star's point here. Here we have 30 galaxies and 10 galaxies, but it is the same sample. So here, this galaxy is here and here, because we use two different methods to infer the star formation rate. And when we use star formation rate by the recent star formation, two methods. This method takes into account the star formation, the Balmer series star formation, and this method takes into account emission in H alpha line. But our galaxies have, at the same time, recently star formation and a little H alpha. At the end of the day, the two opposite results to the same galaxy confirm to us it's a transitional object, because here we have recently star formation, and here we have that this galaxy is still forming stars, but here. And that's it, guys, I think. And okay, the preliminary results again. Other results we find about the environment. We found 0 occurrence when cross-matching this sample with galaxy groups and clusters. When they have lots of galaxies, these galaxies, Post-Starburst is not in this environment. So, as they are found isolated or in low density environments. And a more comprehensive analysis will be done in the future when, as we extend our measurements to the galaxies, all the galaxies of the survey. It's about 2 billion galaxies with spectra. For this work, we use 30,000. And now we are taking measurements using another method, Sloan, that we believe is more appropriate to larger surveys as the SDSS. And we intend to compare the measurements and so